This video is for a continuation of the assignments on factoring for Math 95. So far we've talked about factoring out a greatest common factor, we've talked about trinomial factoring, we've talked about factoring by grouping, and the last kind of factoring I want to talk about is factoring a difference of squares, which is actually a special kind of trinomial factoring. So let's see. When I used to teach Math 70, I gave this assignment. I got it from a textbook, and I really liked it. Let's see. How does it go? It says x squared plus kx minus 36. And the question says, what values of k will make this thing factorable? So we don't have to get too deep into this, but the idea here is that any value of k that is a difference of the factors of 36 will make this factorable. So let's look at the factors of 36. 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. So what this is saying is that, like, if we had x squared plus 35x minus 36, then it would factor like this, okay? And if we had x squared plus 16x minus 36, then it would factor like this, and so on, okay? Now, the reason why I want to talk about this is this last one here, 6 times 6. What's the difference between 6 and 6, right? This middle number I was getting by doing 36 minus 1 is 35, 18 minus 2 is 16, and so on. But if we get down to the 6 and the 6, what we're seeing is that the k would be 0. And we would have x plus 6 times x minus 6. There we go. And this would be x squared minus 6x plus 6x minus 36. These cancel each other out, and so what we get is this x squared minus 36. So this is a difference of squares, okay? That's this kind of factoring that we're talking about right here. And this is why I say it's a special kind of trinomial factoring, is because that middle term turns out to be 0, because when these two numbers are the same, here and here, and they have opposite signs, they cancel each other out in the middle. Okay? These front ones have to be the same as well. We'll see that when we get into some examples. So that's the basic idea for factoring out a greatest common, for factoring a difference of squares. So let's look at some of the examples from the assignment. They start out pretty straightforward. Problem 2. We've got m squared minus 25. So the trick here is, number 1, recognize that it's a difference of squares. These are both perfect squares. This is 5 squared, this is m squared. That means we can factor this as m plus 5 times m minus 5. And you can write the minus part first if you'd like. Both of those are correct. Okay. Then in problem 4, we see one where the leading coefficient is a 9, right? Also a perfect square. Problem 4, we've got 9a squared minus 100. Okay. So again, first we want to recognize that this is a difference of squares. This has to be minus. This is 10 squared, and this is 3a squared, right? The 9 is 3 squared, and the a squared is obviously a squared. So we can split this up and make it 3a plus 10 times 3a minus 10. Okay, let's see here. Problem 6 is very similar to that, as is problem 8. Problem 10, we've got 144 minus y squared. There's nothing wrong with this. It's still a difference of squares. 144 is 12 squared, and here's the y squared. And so this will split up as 12 plus y times 12 minus y. let's see here. Problem 12 is again pretty straightforward. Let's see here. 64x squared minus 25y squared. So again, these are both perfect squares. This will be 8 times 8. This is 5 times 5. So this will be 8x plus 5y times 8x minus 5y. And if you're ever not sure if something's a perfect square, you can square root it on the calculator, see if it comes out to be a whole number. It's good to be familiar with the perfect squares of 1 through 10, which will take you from 1 to 100, right? What are they? So you've got 1 squared is 1, 2 squared is 4, then you have 9, 16, 25, 36, 49, 64, 81, and 100. Okay, so it's good to be familiar with those, if nothing else. All right, now we get into the problems that are technically not a difference of squares. If we can look at problem 14 here, this problem is not a difference of squares. 18a squared minus 2a to the 4a. Okay, so not a difference of squares. But, and we'll see this in the problems on the rest of the assignment, okay? We're going to be combining a couple of different kinds of factoring in the same problem. So the first thing I would recommend that you look for is a greatest common factor, because that'll just make all the numbers smaller, right? We've got a common factor of 2 here in the coefficients. We can also factor out a squared from the variables. That'll leave us with 9 minus a squared. Now, what's inside there is a difference of squares. And so we can factor that as 3 plus a times 3 minus a. And so there's the factorization for the original expression in problem 14. All right. Let's look at a couple more of these. Problem 16 is a good problem here. It has a lot of similarities to problem 14. Here we've got 2x squared minus 50. So again, it's really helpful to recognize that you've got a common factor of 2 in here, and then after you factor that out, what's left is a difference of squares. So this will be 2 times x plus 5 times x minus 5. Okay, let's see here. And then we'll look at problem 18. And these are kind of leading into the rest of the assignment. The rest of the problems on here frequently have a greatest common factor that you can pull out and then look to see if you can do one of these other kinds afterwards. So let's see, we start out with 27 a to the third minus 48a. Well, in terms of numerical common factors for the coefficients, 27 is 3 times 9. So check to see if those numbers divide into 48. 9 does not divide into 48, but 3 does, okay? And I encourage you to use your calculator to determine that. If you don't recognize it right away, then it's helpful to use the calculator. So we'll factor out a common factor of 3, and they both have an a in there too. So this will leave us with 9a squared. And if you do 48 divided by 3, you should find that you get 16. Now, this is a difference of squares. And so this will be 3a plus 4 times 3a minus 4. Okay, so there's an introduction to the ideas of factoring a difference of squares. Now, we're going to look at problems that are all mixed up, okay? And the idea is that we just want to factor them to break it down into prime factors. So let's see how this works here. We'll start with problem 20. 6x squared plus 18x plus 12. So again, I encourage you right away, look for a common factor, because pulling a common factor out will make all of these numbers smaller and then hopefully easier to factor. So we've got a common factor. You could see a 2 right away, but there is a common factor of 6. Okay? And it's fine. If you pulled the 2 out, then you'd have to pull another factor of 3 out afterwards. Okay? So let's see. This will be x squared plus 3x plus 2. Now, we want to look at this part. This is what I was saying. Notice how these numbers are smaller. I think that makes this easier to factor. So this should split up into x plus 2 times x plus 1. All right. Let's see here. Problem 22. We've got a 3xy squared minus 27x to the third. Okay, so it looks like we've got a common factor of 3 here, as well as an x. And then that'll leave us with y squared minus 9x squared. So this is a difference of squares inside here. And we can split this up, y plus 3x times y minus 3x. Okay, let's see here. Well, these are all pretty good example problems on this first page here. Problem 24, we've got 2t squared minus 10t minus 28. So again, right away, I would recommend that you look for a common factor here. And if we do that, then we'll pull out the 2 and be left with t squared minus 5t minus 14. And again, now that these numbers are smaller, it should be a little bit easier to factor this. 7 times 2 is 14. 7 minus 2 is 5. So we want to split that 14 up into 7 times 2. This 5 is negative, so we need the 7 to be negative and the 2 to be positive. All right. Now, problem 26, notice, well, first off, notice the trie in trinomial. That means there's 3 terms. So anytime you see 3 terms, you should start thinking of trinomial factoring. A difference of squares has 2 terms in it, generally. Okay? And so when you see 2 terms, you should be thinking difference of squares. And the reason why I'm talking about this, problem 26 has 4 terms in it. And that is a hint that you're going to be doing factoring by grouping. Okay? That's the way that factoring by grouping works, is that you've got these 4 terms, right? And then you split it down the middle, factor out from the first 2, here it'll be an A. Notice this minus sign, that means we want to factor out a minus 2, and that'll also be A minus B, right? When you factor out a negative, that'll change this sign, make it negative, and it matches this one, which is nice. That allows us to factor it out as a common factor, and there's the factorization for number 26. Yeah, that factoring by grouping, I think, is the trickiest of all of these. Some people may find it to be straightforward. That trinomial factoring can get a little bit tricky as well. Let's see here. All right, problem 28. 16x squared. 28x minus 10, was that it? No, 36x minus 10. Okay. There we go. So again, we have a common factor here. These are all even numbers, so we should factor out 2. That'll be 8x squared minus 18x minus 5. So let's see here. The 5 is prime. So that has to be 5 times 1. The 8 could be 1 times 8 or 2 times 4. So I'm going to start trying the 2 times the 4. Let's see, I'll put the 2x here and the 4x here. And remember, the key is that these two multiplications need to have a difference of 18. And in this case they do, right? This is 20 minus 2 is 18. And let's see, we want a negative 18, so we need the 20 to be negative and the 2 to be positive. So there it is. Let's see what we've got on the next page here. Okay. Problem 30 is very similar to some of those problems we were doing a few minutes ago in the difference of squares section. Right? So you notice there's 2 terms here. That starts me thinking difference of squares right away. Even though, right, we don't see the perfect squares here. But we do see the common factor of 5. And after we factor that out, there's the difference of squares. 5 times x plus 3 times x minus 3. Okay. Problem 32 looks similar to that. Let's see what that one looks like. 7p to the third minus 28p. So here we've got a common factor of 7, and the p as well can get factored out. So that'll leave us with p squared minus 4. Again, a difference of squares. That'll factor as p plus 2 times p minus 2. Okay, let's see, there's a couple more on here. Let's see what these look like. Problem 34. We start out with 6x squared minus 2x minus 20. I'm getting ahead of myself here. This is supposed to be 20. There we go. But after we've got a common factor of 2 here, so we should be able to factor it out, and then we'll have 3x squared minus 1x minus 10. And this is trinomial, so we should try the trinomial factoring. The 3 is prime. It can only be 3 times 1. And now the trick is we want to fit those factors of 10 in there. Right? 1 times 10 or 2 times 5. I'll start with these two. And I'll put the 2 here and the 5 here. We want a difference of 1. This will be 15 minus 2 is 13. That doesn't work. So let's swap the 2 and the 5. And there's 6 minus 5 is 1. Excellent. Now, notice that we want a negative 1. That means this 6 right here has to be negative. And the 5 right here has to be positive. Okay. Let's see here. Problem 36. We've got 8a squared minus 14a plus 5. Let's see here. Well, the 5 is prime. That can only be 5 times 1. And let's see, the 8 we were just talking about a minute ago with the 2 times 4 and the 1 times 8. So let's try to put the 2 and the 4 in there. And now we want this and this to add up and be 14. So yeah, 10 and 4 make 14. And this tells us we should have minus and minus. Okay, last problem here. Let's see what this one looks like. 4x cubed plus 14x squared minus 30x. Okay, so right away, I can see there's a common factor of 2, and we've also got an extra x hanging around. So let's see, this will be 2x squared plus 7x minus 15. So let's see if we can factor this. Get a 2x and a 1x, right? The 2 is prime. It can only be 2 times 1, so let's just put them in there, and then we'll test out the different factors of 15. We can have 1 times 15, or 3 times 5. I'll start with the 3 and the 5 and see how that goes. We're looking for a difference of 7 again. And I think that's going to come if we take the 5 and put it here. That'll give us 10, and then minus the 3 would be 7. And we want the 10 to be positive, and we want the 3 to be negative. So there we go. Okay. So, you've got an answer key along with this assignment so you can see the factorizations. And as always, if you have any questions, please let me know. I am running the Zoom Math Lab from noon until 2 p.m. Tuesday through Friday. You can check in with me there. If you have questions outside of, email or the Zoom classes that we're doing on Mondays. So, as always, if you have questions, please let me know. Thanks.